The last question from section 3.3, zeros of polynomial functions, is the following. Find all zeros of the function f of x, which is equal to a times the quantity of x minus 1 squared times the quantity 9x plus 5 times the quantity x squared minus 9 and their multiplicities. So to find the zeros of a function, if it's in factored form, you're going to set each factor equal to 0 and solve for x. Now this function can be written as f of x, which is equal to 8 times the quantity x minus 1 squared. That's x minus 1 times x minus 1. We say that's a repeated factor. So when we find the 0 for x minus 1, we're going to say it has a multiplicity of 2. 9x plus 5 and x squared minus 9. We're going to set each of those factors equal to 0. Now, it wouldn't make sense to set 8 equals to 0, so we're going to start with x minus 1. If we set x minus 1 equal to 0 and add 1 to both sides, we get x is equal to 1. That's a 0 of the polynomial function, and we say it has a multiplicity of 2 because it is a repeated factor. The entire quantity squared, we say, has a multiplicity of 2. Now we're going to set the other factors equal to 0. So if we set 9x plus 5 equal to 0, subtract 5 from both sides, we get 9x equals negative 5. Divide by 9, and we get x is equal to negative 5 over 9. That's another 0 of the polynomial. And then finally, that last part, we set x squared minus 9 equal to 0. If we find x squared is equal to 9 and take the square root of both sides, we get the square root of both sides. We get x is equal to positive 3 or x is equal to negative 3. So we have the following zeros. We have 1, which is a multiplicity of 2. That's a 0, negative 5/9, positive 3, and negative 3. And the one that has a multiplicity of 2 is x equals 1. That looks like the first choice here. Our zeros are 1 with multiplicity of 2, negative 5/9. Oh, nope, sorry, wrong one. Choice C, 1 has a multiplicity of 2, negative 5/9, a positive 3, and a negative 3.